Hello everyone, I am Mrs. Poonam Shinde, Assistant Professor from the IT Department, Pune Institute of Computer Technology. So today we are going to study analysis modeling, which is the core topic in software engineering or in ESDM. This topic comes under requirement analysis, which is a fundamental of any software project. If requirements are not clear, then even a good coding and design will fail. So before development starts, analysis modeling plays a very important role. So in today's lecture, we will cover what is analysis modeling, types of analysis modeling, then scenario based modeling, use case diagram and activity diagram. By the end of this session, you will be able to draw and explain UML diagrams used in requirement analysis. So, let's start with what exactly analysis modeling is. So, analysis modeling focuses on the system, what the system should do, not how it will be implemented. Yes, so it mainly concentrated on three aspects, that is information to be processed. So in this, what data will enter in the system, what data will be stored, updated or displayed, it is comes in information to be processed, then function to be delivered. Yes, so in this, what operations will the system perform? Example, login, register, search, payment. It comes under function to be delivered. Then next we have behavior to be exhibited. Yes, so in this, how will the system react to the different situations? For example, if there is a wrong password, if the server get fails, then if there is any invalid input from customer side or user side, then how the system will react to this situation, it comes in behavior to be exhibited. So analysis modeling helps us identify the real problem and understand user expectations very clearly. I hope you clear this. Okay. So next we have types of requirement analysis, or we can call it as a types of analysis modeling. So first we have, so there are different types of models used to represent the requirements from different viewpoints. So first is scenario based model. So scenario based model focuses on user interaction with the system. So scenario based models of requirements from the point of view of various systems called as actors. So actor is nothing but the users. Then we have data models. So the data models that depict the information domain for the problem. So it shows what type of data the system will handle. Next we have class based models. So class based models represent object oriented classes, that is nothing but the attribute and operations, and the manner in which classes collaborate to achieve a system requirement. So it represents classes, attributes and operations in a object oriented systems. Next we have flow oriented models. So flow oriented models represents the functional elements of the system and describes how they transform data as it moves through the system. So it shows how the data flows through the system. Next we have behavioral models. So behavioral models describes how the software behaves as a consequence of external events. So the most common method of creating these diagrams is UML. So UML is nothing but what? Unified modeling language. So behavioral models describes the system behavior based on its action, or we can call it as a event. So most of these models are created using UML language or unified modeling language, which is an industry standard modeling language Yes, so we'll see it one by one. So these are the this is the structured analysis of or object oriented analysis. So in this we have scenario based modeling. So in scenario based modeling we have use case test, then use case diagrams. So we are going to see how to draw the use case diagrams, activity diagrams, then swim lane diagram. And in class based modeling we have class diagrams, analysis package, CRC models, collaboration models. We are going to see it one by one. So there are two major approaches in analysis model. So first approach is object oriented analysis and second one is structured analysis. So structured analysis focus on the functions and data flows. It uses the DFT, like data flow diagrams, and it is suitable for traditional procedural systems, whereas object oriented modeling focuses on the object classes and relationship. So it uses UML diagrams and it widely used in modern software development. So in today's software engineer industry, object oriented analysis is more commonly used. So first of all we are going to see the scenario based modeling. So scenario based modeling helps us to understand how end user interact with the system. So scenario based modeling is used for building of analysis and designing model, and it is essential or useful for software engineers to understand how the end users and actors or stakeholders want to interact with the system, and identify the possible use cases for the system, and it produces the diagram to which all the other stages and requirements model refers. So here users are called as actor, and scenario based scenarios describe step by step interaction. So in this modeling it identifies the possible use cases, then helps in understanding the functional requirements and act as a base for all the models. So there are mainly two UML diagrams are used. So these are we are going to see use case diagrams and activity diagram. So first of all we'll see use case diagram. So a use case diagram visually represent actor, system and communication link. Okay, so here actor is nothing but who uses the system. So actor is the user that interact with the system. So an actor can be a person, an organization, an outside system, stakeholders. So there must be external objects that produce or that consume your system data. Okay, next we have system. Okay, so system is nothing but a specific sequence of the action and interactions which happens between the actor and the system. A system may be also referred as a scenario or behavior. Then we have communication link. So communication link, the participation of an actor in use cases shown by connecting the actor. So what is use case? So we know actor, now we know what is actor, system and communication link. So communication link is basically used for connecting the actors and the use cases. So use case is nothing but what the functions the system is going to provide, or what the system what the different functions system is providing. Okay, so it gives a high level functional view of the system. So use case diagrams helps in helps developers to understand the system scope, then for clients to verify the requirements, and it analyst for analyst to avoid a missing functionality. Okay, so here you can see this is a use case diagram. So here is the explanation we have for this. So you can see here we have use case, relationship. So first relationship is extend. Okay, so Extend relationship is used for optional or conditional behavior. So based on use case works independently. Extended use cases executes only under a specific condition. For example, if invalid password, then we are going to extend a login account. So you can see here, if my password is invalid, it extends the login account. That extension point is what? Your password is invalid or invalid password. So it represent, the extend relationship is represent using a dotted arrow and using a extend stereotype. Okay. Yes. So next we have include. So include is when the use case describes or when the use case shows using a functionality of another use case, the relationship between the use case is named as a include or use relationship. So this use case place order is what? It is a use case of another use case, that is a login. So we are going to place order through the login only. So same like extend, we use a dotted arrow with a include stereotype here. Okay, next we have generalization. Yes, so generalization is generalization represent a parent-child relationship. So parent use case is a general behavior. So you can see here, patient record is what? It is a general behavior, and we have a child use case, that is specialized behavior. So we can see here, we have a store patient record file, that is a computerized file, and then we store a patient records, that is a paper file. So through the computerized file we create a paper file. So this is what one example. So it direct we have here, we don't have direct dotted arrow, we have a directed arrow with a triangle arrowhead for generalization. And for example, payment. So payment, through payment we have, so payment is what? It is a parent behavior, and your payment may be credit card payment, or it can be a UPI payment. So it is your child behavior, generalized behavior. So we are here will come here your payment will come, and it here maybe a credit card payment or UPI payment. So this is the example of your generalization. Okay. Yes, so this is a use case example. So this diagram shows a real world example where actors, you can see here we have actors like cellular phone, customer, then external phone company. So these are the actors or some external objects we have in our system. So these actors, you can see these actors interact with the system functions. So we have a system functions like handle a message, then handle call, then manage a bill. So relationships are clearly defined. So here this is the boundary system, and you can see in ellipse we use ellipse for showing a use case, or use case is nothing but what? It is a function, or we can call it as a it is a yes. So this is a function which we implement in our system, and we have a system boundary here, and this is an association, that this actor is having two activities, or it is interacting with two functions. So this is association symbol. I hope you understand this example. Okay, so this is one example. You can see here we have a actor, that is a bank customer, and another actor is called as a system, or we have a actor which is interacting with the system using some use cases. So you can see here we have a use cases like enter PIN, then choose a cash withdrawal, enter a cash, then enter amount. And when the customer use a function or bank customer use a function, for example enter amount, after entering amount it goes to the system. Okay, so system will do some process or system will do some operations, and after that it gives a response to the actor that transaction done and your cash will be withdrawn. So pick your cash. So this is how the interaction happens using use case diagram. So in use case diagrams we use use cases for interaction between your actor and your system. Okay, so this is also one example of supply chain management using use case diagrams. Okay, next we have activity diagrams. So an activity diagram represents the workflow of the system. So activity diagram shows the steps involved in your system to helping us to understand the flow of your flow of control, and the display the order in which activities happen and whether they occur one after other or sequential or concurrent. So it is represent using your activity diagrams. So it shows a sequence of the activities, then it shows the decision and parallel processing. So activity diagrams are used to explain business logic, then system flow and user interaction steps. So before starting activity notations, what are the features of activity diagram? So an activity diagram starts with an initial node and it ends with a final node. It contains the activities, decisions, flows, supports a concurrency, and it gives a dynamic view. So we have some notations. So this is a guard notation, then we have a fork notation, join notation, merge notation, time event, control flow. So we'll see the description of each, we are going to see each notation in detail in next slide. So what is activity? So activity is what? Activity is used to represent a set of actions or group of actions. So we use here one rectangle with curved corner. So curved rectangle is used to represent set of actions. It's called as a activity. Then we have a action. So what task is to be performed, what function to be performed, we are going to draw this using a curved rectangle. Yes. So then we have, or it is a single task and it is a group task. Okay, so action is what? It is a single task, and activity is what? It is a set of tasks. Then we have a control flow. Okay, so control flow is what? Control flow or activity diagram notation control flow using a arrow. So arrow is used for showing a execution sequence. Okay, next we have initial node. So initial node is what? It is a starting point of your activity diagram, or it is starting or initial stage of your beginning of your set of actions or activities. Next we have activity final node. So it is here this node notation is used to stop all the control flows and objects, or it is a final stage. Okay, then we have object node. So object node represents the object that connected to the set of object flows. So we use here one rectangle for rectangle notation for object node, then decision node. Yes, so decision node is used for test condition. When we have if else or yes or no, that time we use decision node. So here we use a diamond shape using a two arrows. Okay, then we have a merge node. So when there are two different paths we want to join, that time we use a merge node. We have a fork node. So fork node is used for parallel execution. So when we need to execute two activities parallelly, that time we use a fork notation. Then we have join node. So you can use you can see here we use this notation for join node. So join node is what? Synchronized parallel flow, and we have swim lane or partitions. So it is a group activities performed by the same actor. We divide activities of the particular actor in partitions. So it is called as a swim lane and partition. So it is used when a system performs a multiple operations simultaneously. That time we use this notations. Yes, so this example shows a step-by-step ordering process. Then it shows a decision point, then it shows a parallel activities, then it shows a merge activities. So you can see here it is a precondition. Then when the actor gives an input, then your first step happens, it is a system step. Then it goes to the extension flow. If it is true, then it execute a step. Whether if it is a false, it goes to the return to the alternative flow. And then you have a step 3. After a step 3, you can see here there are two parallel activities, or we need to execute two activities parallelly. And after execution of these two activities, again we are using a merge notation or merging these two activities, and then we have a post condition, or we can set it as a final node. So this is how we draw a activity diagram. So this is example of placing an order. Once you receive a order, there are two parallel activities we are going to perform. First we are going to fill order, and we are going to send an invoice. Once the order is filled, if you have rush order, then arrange overnight delivery, else arrange regular delivery. Once this happens, we are merging these two activities together, and then it is, you can see here we are receiving a payment, and after your delivery is ready and you receive a payment, then you go for the final stage, that is final or end state. So this is how we draw a activity diagram. Yes, so let's move to the quiz. So first question is, analysis modeling mainly focus on which of the following? So options are coding structure, hardware configuration, understanding system requirements, or database optimization. Yes students, what will be the right answer? Just think and tell me the answer. Yes, so understanding system requirement is right answer. So next question is, scenario based modeling focuses mainly on, options are data storage, user interaction with the system, algorithm efficiency, and hardware design. Yes, what will be the right answer? Yes, so right answer is user interaction with the system. So third question is, activity diagrams are mainly used to show, options are static structure of the system, object relationships, sequence of the activities, and database design. So what will be the right answer? Yes, just now we have seen the activity diagram. So activity diagram is used to show sequence of the activities. Yes. So to summarize, analysis model helps understand requirements clearly. UML diagrams reduce ambiguity, and use case and activity diagrams are essential tools. A strong analysis phase leads to successful software development. Yes, that's all for today. Thank you so much, students, and always remember, the more you learn, the more you grow. Thank you so much.